Hello, this is Nitin Dahad with EE Times. I'm talking to Ying Chen, who's a VP of Sales and Marketing at S2C. Ying, hello.
Hi, Nin. How are you doing?
Good. Well, Ying, we met last at the RISC-V Summit in Santa Clara, and you had a large suitcase, and we're going to come to that large suitcase story in a little while. But before we do that, let's just learn a little bit about S2C. What do you do?
Sure. S2C, we specialize in EDA, especially in the realm of functional verification. We were founded in 2003, first in Silicon Valley. Now we have headquarters in Shanghai, which was established 2004. So we have been around for 20 years. But we are mostly well known for FPGA prototyping. We have had the first product since 2005. So that's what we are known for. But in addition to FPGA prototyping, we are now investing in other parts of the other verification tools, simulation, emulator, and even virtual prototyping.
Okay, that's quite a sort of all-encompassing answer. Give me a couple of examples of products and things you do. Maybe you can start with the new product, just say what that does, and then maybe we can go into some of the other lower end.
Sure. Maybe I can just elaborate on what FPGA prototyping is all about.
Yeah.
So when you do a chip design, it's very important for you to make sure that the chip is functional correct before going to tape out or place and route and tape out. And so FPGA prototyping provides a high performance tool in terms of hardware using FPGA to really be able to test the design almost at speed or near speed in system to catch the last mile bug.
Yeah.
And also another good application for it is to provide the system to a software engineer after the design is stabilized, so that the software engineer can have a prototype or working vehicle to start developing the firmware, the software early on to achieve shifting left, right? Otherwise, the software engineer have to wait for the first silicon to come back, which is much 12 months or 18 months later.
So I mean, in a development flow, say I might have already done some work, traditional EDA tools, and I'd probably tape out, and then we come to. This would be before tape out, obviously. Yeah. So you've done all your sort of design verification, and then you want to then figure out how it works in real time.
Actually, this is part of the design verification. So some the other common tools is like simulator, RTL functional simulator, but because it's software based, it's only capable of verifying a smaller IP block. There's also emulator, which is a hardware accelerated verification tool. Okay. Very big, very expensive, but it's like a truck. If I draw a comparison between emulator versus FPGA prototyping, emulator is a huge truck which runs slower, but it gives you more capacity and more services.
Yeah.
With FPGA prototyping, it's all about performance.
Okay, good. Now let's come to the suitcase. So it's a new product you launched. You are taking around in the US to customers. Tell us what it is.
Sure, and I just mentioned FPGA prototyping is all about performance, right? So that way you can run at speed, or you can give it to a software engineer who needs that kind of high performance. Therefore, using the biggest FPGA out in the market really helps, because
that was a Versal, I think.
That's the Versal Premium VP 1902, the latest and greatest flagship FPGA from AMD.
It looks massive and impressive. I have a picture, and I would say that's probably much smaller than a truck.
Yeah, because if you don't have to partition, your design can run more than 100 megahertz. And that's why the size does matter. Yeah. So we are probably one of the earliest vendor to have shipping products. So that was actually a working unit, and which was, I think we met about 2 weeks ago, right?
Yes, that's right.
So at that time, we have already shipped 10 systems.
Okay.
Yeah.
So you say you've sold 10 systems already. What kind of customers, what kind of work are they doing with that? Obviously, prototyping large chips, I guess.
Yeah, well, the chip designs are just getting bigger and bigger. So, but the chip design do vary of different sizes. So they do for the most part, they do want to use the FPGA, biggest FPGA possible.
Right.
But since that FPGA was just went into production, and that was our first single FPGA configuration, we expect to have more customers with bigger design that will purchase our dual quad configuration and interlink multiple systems to support bigger designs. Having said that, I think the ones who are buying our current system, buying the single ones to fit the smaller design.
Right.
But we also have a smaller capacity FPGA prototyping system because we are a one-stop shop. We will try to provide solutions for all our customers. So we are not limited to just the big ones, but smaller ones. And I've been talking mostly about hardware, right? But what's also quite important is the software, the IPs that can help customers with debug. So that's how we differentiate from just a FPGA vendors, eval boards, or PCB maker.
With your competitors. So,
Yeah.
So, sorry, go on.
Yeah, so we are pretty much on par with the most well-known FPGA prototyping vendor, which is Synopsys, with their HAPS series. They have been around for a while as well, so have we. Obviously, they have other tools to bundle as well, but for us, we are not just a hardware maker. We actually have our own tools to provide partitioning capability, debugging capability, and one thing that we recently found to be quite interesting is, especially with RISC-V application, because RISC-V is developing so quickly, and there's so many different variants. You also have low end, mid end, and high ends, and people are looking to use RISC-V because of PPA optimization. So the high end doesn't necessarily is the best, right? You want to find the one that's matching optimal.
Exactly.
So with our FPGA prototyping, it's a good carrier for you to realize whether and to implement the RISC-V IP to figure out what kind of performance you can expect. And then when it comes to system level testing, you also have to have other peripherals, PCIe and memory.
Yeah.
And I know this is going into details, but the FPGA that we're currently using only supports DDR4.
Okay.
But in reality, most of the consumer electronics, IoT, DDR5 is quite important.
Yeah.
If we are just testing with quote unquote DDR4 substitute, it's not going to be accurate, and you won't be able to really get a good sense of what kind of performance or whether this SoC is what to implement. And we actually have IPs to map and support the memory controllers, which is not natively supported by the FPGA.
So it plugs into the system, basically. Exactly. Okay, that's interesting. What are the key trends right now? Obviously, the big thing is chips are getting larger, more complex. You're looking at more and more AI, but also you're looking at the other end where people are looking at edge in AI. So I guess there's sort of like two different trends going on.
Yeah.
From where you sit, so you're addressing both ends of the market, I guess.
Well, yes and no, because even with edge AI, unless it's purely IoT without the AI.
True, it can be a big system.
Yeah, edge AI could still be big.
It could be a F-35 for all we know.
Yeah, so it's the difference between relatively small AI and a big AI is the difference between 1 to 8 FPGAs or 32 to 64 FPGAs. So in general, they're quite big, and that's what we have been focusing on improving our partitioning software, and also when the latest and greatest FPGA comes out, we are well prepared to roll out the system very quickly.
For when you're doing FPGA prototyping, does it take into account all the different things that you need to account for in, say, for example, automotive, like the the standards and things like that, or is that something that comes later?
It does come later. So because with the FPGA prototyping, it's really meant for all types of designs.
Okay.
But we would also develop daughter cards and IPs and reference designs now would cater to different applications.
Right.
So for example, when it comes to RISC-V or in general SOCs, we have to look at what's the best way to partition, maybe over a AXI bus, or look at what's the best way to do debugging, specifically for RISC-V. Because RISC-V is still in its, I guess, growing phase. So we're also trying to work with the different RISC-V IP vendors to try to understand their pain points and implement more features into our software.
Now, I'm always conscious when people talk about RISC-V in terms of balancing their business. It's still probably a small part of your business because there's still a lot which is not RISC-V, I guess.
Yes, but just because RISC-V is up and coming, and like I said, there's so many different variants. That's why they so there's even more demand and interest in using FPGA prototyping as a demonstration unit.
Which turns into revenue for you, I guess.
Exactly. If everything is fixed and well-known and mature, they probably don't need to do that much exploration.
Got it. What's your company's not a startup, it's been going for many years, so you're pretty well established, big geographic reach, as you said, China and US. So what's next for S2C? What do you want to do?
Well, since we are actually based here in China, and there's definitely a lot more semiconductors new developments here. So in addition to FPGA prototyping, we're also developing tools like a simulator, emulator, and virtual prototyping. So to provide a more comprehensive portfolio of verification related tools to the customers here. And China is actually a good starting point because the customers here are pretty eager to provide feedback, and that way we can roll out our products and improve the products. So when it's mature, we will try to promote them, those products outside of China as well. Granted, simulator is probably more challenging because there's de facto standard out in the industry, but tools like virtual prototyping or emulator are something I think a lot of customers are looking forward to having an alternative.
Okay. What's the most exciting part of your job? What do you like about this?
Well, what I like is really taking our products, especially with FPGA prototyping, because it is actually programmable. I was in the FPGA programmable industry for 20 years.
Okay.
And
so we probably know a lot of common contacts as well.
Exactly. And it's similar to FPGA. We're really taking this programmable platform and see what are other applications. And one thing I kind of alluded earlier, in addition to just doing hardware verification or software development, this is a great vehicle for startups to really use it as a proof of concept to show to their investors or to their early customer to really get feedback, right? So it's really trying to understand their pain points and how we can provide some customization on top of the standard products to address their needs.
So it lived up to its launch in the 80s when it was supposed to do that. It's still doing that, I guess.
Yes, it's a niche because one thing that doesn't change is innovation always happens, and you need something that's flexible.
Yeah.
Yeah.
Well, good. Well, Ying, thank you very much.
All right. Thank you very much, Nin. Yeah.